Welcome to the Construction Documents and Services Building Section Vignette. I am Raleigh Sullivan and I will be guiding you through this vignette. So buckle up and let's go. Following this drawing task list, you are guaranteed success. Number 1. Read the program carefully and make notes. Number 1 is in bold because it cannot be overstated. You must read the program carefully and you should make notes. Please remember to read the program carefully and make notes. Draw the grade line. Without drawing the grade line, you won't pass the vignette, so please do that too. Draw interior and exterior footings at the proper depths. The program tells you how deep the frost depth is, and your exterior footings must reach that point. Draw a ceiling. Block out space for lights. This is sometimes a tripping up point. Don't trip up. Determine largest duct joist combination. Yes, it sounds complicated. It is. Place joist size and orientation per plan. Place ducts sized according to the section cut and not in the space for lights. Repeat these 8 steps for each space. Extend the parapets per instructions. Adjust and fine-tune as you go so that you don't have to redraw anything. And number 12, check your work. As pointed out in the steps for solving this vignette, reading the program and taking notes is key to success. I will now read the program. Please take notes as I do so. The structural system consists of a top chord bearing steel joists on masonry bearing walls with continuous concrete spread footings and a concrete slab on grade. Number 1. All ceilings and roofs are flat. Number 2. Non-bearing corridor and lobby walls have a minimum fire resistance rating. Number 3. Exterior and bearing walls have a 2-hour minimum fire resistance rating. Number 4. The ceiling height of the laboratory is 15 feet. The ceiling height of the remaining first floor spaces is 8'4", and the ceiling height of the second floor spaces is 9 feet. Number 5. Ceilings are used as return air plenums. All ceilings are non-rated. Number 6. Assume fire and smoke dampers and transfer grills are provided as needed. Number 7. The space between each ceiling and floor or roof slab must be held to a minimum dimension required to accommodate light fixtures and the structural and mechanical components shown on the plan. All ducts are placed below the joists. Number 9. Provide 8 inches of clearance between the bottom of all the ducts and the finished ceiling to accommodate light fixture. Number 10. Parapets must extend 2 feet above the top adjacent roof decks. And lastly, number 11. The frost depth is 5 feet below grade. First, place your grade line. I like to draw the grade line right on top of the plan. It's important to draw the grade line because without it, your vignette section can't be graded. Now put the footings in. Just plop them in their general locations, and we will precisely adjust them when we zoom in a moment. We need footings at all exterior walls and any interior bearing walls. Note that the program states a frost depth. In our case, it must be at least 5 feet deep. There are 2 ways to do this. One is to have the top of the footings base be at the frost depth, and the other is to have the bottom of the footings base be at the frost depth. Either way is okay as long as the frost depth requirement is met. If you go longer than the frost depth, it could be considered wasteful of materials, and if you go shorter, then you won't be meeting the program requirements. I zoom in and draw sketch rectangles to verify that my footings are at the correct depth. In this case, the bottom of my footings is at exactly 5 feet. The internal footing is different because it doesn't have to deal with frost heave. So it would simply be a footing under the slab. Now we can place our slab on grade. Just plop it into the drawing. Once we get the slab element into the drawing, we will zoom in and fine-tune the placement. Note that the slab sits on the grade line, with the top of the slab above the grade line. Make sure that you don't accidentally put the finished floor level even with the grade line. The top of slab must be above grade. Also, the slab is broken here at the internal footing. This is because the bearing wall should rest directly on the footing and not on the slab. We'll go ahead and put the bearing walls in now. Just like with the other elements, we'll quickly plop in the bearing walls, and then we'll fine-tune, adjust them when we zoom in. So it sits right on top of the footing. Now we'll work on the interior footing. Here we click the Move Adjust tool, lay the wall down right on top, and then we'll adjust the slabs to make them touch too. We're good to go there, and we don't have to come back and check on that. Now we'll adjust this one, put it right on top. Our foundations are done. We can now move on to the ceiling. We look in the program notes and we see that the first floor ceiling height is 8'4". So the first thing we'll do is draw a sketch rectangle at exactly 8'4". At exactly 8'4". Kind of zoom in to make sure that we really did get it at 8'4" and not just a little bit off. Now that I have the sketch rectangle at 8'4", I can draw in my ceiling element, and I'll put it right on top, and then I know my ceiling is at 8'4". I'm going to zoom into that corner and adjust it so that my ceiling just touches the wall. I like to make these kinds of adjustments as I go so that I don't forget about it later. I didn't draw the ceiling all the way across because I know that it will be broken by the firewall and the interior partition. So let's go ahead and draw the firewall and interior partition. We read in the program that the non-bearing corridor and lobby walls will have a 1 hour minimum fire resistance rating. So with this in mind, we know that all the walls along the corridor and lobby need to be rated. We can see that the closet wall is not rated because it doesn't touch either the lobby or the corridor. So we will place a non-rated wall in the closet and office space. We see the other side of the closet borders on the corridor, so it must have a rated wall. Also note that the program tells us that bearing walls are 2 hour rated. So the other side of the corridor has a bearing wall. By dint of this fact, we don't have to do anything because it's already rated. Now that we have our partition and firewalls in plan and aligned with with where they're supposed to be, we can place the ceilings for the rest of the first floor. Now I just dragged my... That's not going to work because it has to be broken there at the firewall. So I'm going to readjust it so that it is 8'4" in the office area, 8'4" in the closet, and 8'4" corridor. And of course it does have to touch the wall, but it shouldn't penetrate the wall. Building on what we've drawn so far, we see the next step will be space for lights. Looking at the program notes, we see we're required to have 8 inches. So drop in a sketch rectangle and draw it across the first floor area. Now zoom in and adjust the sketch rectangle to be exactly 8 inches. The space for lights can sometimes trip people up because it is easily overlooked. The space for lights is required space in addition to any space needed for ducts and joists. We are not given a drawing object for the lights, so we will leave the sketch rectangle here as a reminder that this is our light space and that the ducts and joists can't go into it. This leads to the next item, which is placing ducts and joists. Though they can't share space, the total interstitial space needed has to be determined by considering the largest duct and the largest joist size combination. By doing this, we are sure that in the worst case scenario, the joist and duct will always have enough room and won't infringe on the other spaces. This is really tricky. Usually the section cut is not cut at this location. The tendency is to simply draw what is at the section cut line without regard for the rest of the building. You must look around at the rest of the building and decide what the minimum interstitial space has to be to accommodate the worst case scenario. Once you've done this, you can draw your joists and ducts in at the proper heights. So we look at the plan and see the joist sizes called out. 24-inch joist at 2 feet on center here, and it looks like everywhere else. And then we look at the ducts, and it looks like the largest size is 32 by 24. Look around a little more to make sure that we're not missing anything. In this case, it looks like these really are the largest ducts and joists, so we'll use them. With this knowledge, we know that the bottom of the joist must be at least high enough for that 32 by 24-inch duct to fit. I'll place a duct and a joist in the drawing and then go back and adjust the elements according to the information that we've just gleaned from the plan. Place the 32 by 24-inch duct. This is just a placeholder to make sure that I get that duct space at the right height. Now I'm going to put in my joist. I know that I want to get 24-inch joist because that's what it says in plan. And I know that the joist will be elevation because the section cut is parallel to the joist. Now that I have that placed in the drawing, I'll zoom in and adjust everything accurately. Move the duct over, put it right on top of the light space, and then get that joist to just rest right on top. Now I know that no matter what happens, the largest duct will always fit into that space without infringing on the lights or going up into the joists. Now I'm going to move the joist over a little bit so that it's clearly bearing on the bearing wall. You don't have to make it do this, taking it in 1-2 clicks, but this way I'm sure that it really is bearing. If you don't, and you just leave the joist kind of touching the wall, you run the risk that it doesn't touch the wall, and if it doesn't touch the wall, it's structurally unsound and you'll fail. Now we're going to place the real ducts that we've got in our section. and we'll just stick them anywhere inside that interstitial space. Can't go inside the lights, can't go up into the ducts, but it can go anywhere in between. Now what size duct are we cutting through there? It's hard to tell because we're zoomed in too close, so kind of zoom down. We'll see they've got a 24 by 16 duct there that our section cut is cutting through. So we'll select that, 24 by 16. Align it, make sure that it's within its allowed space. Good. Now we have that first floor pretty much done. We can move on to the second level. So turn our layers off for the first floor, turn them on for the second floor, press OK. Go ahead and extend those walls on up because we're going to need them. We're just going to place the items in, put that ceiling in, put it in again. We know it'll be broken because we know we've got a corridor there, so we'll have a firewall. And we'll go ahead and put in that firewall. Again, I'm just kind of plopping them into the drawing, and then we'll zoom in and adjust them precisely in a moment. I'm going to go ahead and put in the joists, and here on the second floor it's still drawing joists and elevation. Now I'm going to zoom in, kind of get that firewall situated. Notice it's a little off the plan, so I'm just going to put it right back on and grab the end of it and make sure that it's resting right on the top of the deck. Zoom out a little bit. Now we're kind of going to look at the ceiling height, and then we'll go into the interstitial space. So looking at the program, we see that the ceiling height for the second floor should be at 9 feet. So I'm going to draw a sketch rectangle, adjust it so that from the top of finished floor up, it's exactly 9 feet. And then move adjust, grab that ceiling, move it over, get it to be right at 9 feet. Move the joist down a little bit so it's within reach. Scroll over, pull that ceiling over to touch the firewall. And I'm going to extend the sketch rectangle it goes into the corridor. Make sure I get the corridor ceiling at the proper height as well. I can touch the wall. I'll zoom out. Okay, so now I'm going to kind of look at this interstitial space. And I know that we need to get the light space in. Don't want to forget that. So I'll draw that first. And it's 8 inches, just like first floor. Move adjust. Let's get that baby to be right at 8 inches. There we go. Now zoom out. We're going to look for that largest duct joist combination. Here you can see 24-inch joist, 5-inch on center, 24-inch joist, 5-inch on center, 5 feet on center, sorry. Now we look at the ducts. Looks like our largest duct is back there at the mechanical closet, 32 by 20. I'm going to zoom in to that interstitial space again. And I'm just going to put the placeholder 32 by 20 duct. And this time I'll do a sketch rectangle, make it be the proper height. Then I can go ahead and delete the placeholder. Looks like my joist was pretty much at the right height now, so I'm going to go ahead and just pull it in, give it the bearing connection. Notice how click on it and didn't do two more little jumps over into the wall. Each little jump is roughly equal to about an inch. So if you can get the joist to be in about 2 inches, that's fine. Alright, so we have the interstitial space basically figured out. All that's left is to place the ducts. And there it looks like we really only cut through one duct on the second floor. It's a 20 by 12, so we'll select the 20 by 12. Kind of right over that corridor area. Using the cursor lines, we're aligning the center of that duct with the center of the duct shown in plan. Zoom out. So now we're pretty much done with the second floor. We can move over to the laboratory, and we're going to follow all the exact same steps we did at the first two spaces. We read in the program that the ceiling height of the laboratory is 15 feet. So draw in a sketch rectangle and zoom in. We'll make sure that sketch rectangle shows us 15 feet above finished floor in the laboratory. We got it at finished floor. Now let's zoom up. Get that thing at 15 feet. There we go. Okay. Zoom into that area. I'm going to move the bearing wall up to kind of get it out of the way. Now I'm just going to drop in the ceiling and drop in another sketch rectangle for space for lights. Now I can move the ceiling over, just extend it over, make it touch the adjacent wall. The ceiling is in. Now I'll do the same thing for the space for lights. Just going to move it all the way over. That way, as I'm working on that interstitial space above the laboratory, I don't forget about it. Now we'll look for the largest duct joist combination. Looks like the largest joists in the laboratory are the 32-inch joists, 5 feet on center. So I'm gonna go to the joist section and get that. Because we're cutting through the joist perpendicular to the section cut, we're going to show the joists in section rather than elevation. Now I'm looking at the ducts, and it looks like our largest duct will be the 24 by 20 there in the mechanical closet. All the others are smaller, but we have to provide room for that 24 by 20. So I'm just going to plop in the 24 by 20. That way I'm sure to get the right size. Over there. And while I'm at it, I'm going to go ahead and put in the actual ducts that our section is really cutting through, the 8 by 8s. I'm pretty much getting them aligned using these crosshairs too. We'll come back and adjust them later, but I know that it can't go into the light space, and I have a pretty good idea of where the joists are going to be, so I'm getting it close. But now we'll zoom in and really get these things fine-tuned. So I just placed the sketch rectangle. Now I'm going to get the sketch rectangle to represent the height of the 32-inch duct. The duct wasn't really sitting right on the light space, so I want to get it to sit on the light space. Now we're good. Now I'm going to move the joists over. And since we're drawing the joists in section, you have to press the Move Group tool. I'm going to just click that in there so it's a bearing connection. Same thing over here, and just kind of click it in. 2 little clicks in, or 2 inches. Now I can use the Move Adjust tool, and I want to get the joist to line up with how it really is in plan. So you can see here that I got the section profile to line up with where the joist actually occur. Alright, so I'm just going to delete that placeholder. I'm getting really close. And it's time for parapets. So the program says parapets are 2 feet above the adjacent deck. So I'm going to make this sketch rectangle be 2 feet. Almost there. Right there. 2 feet. And then I'll just adjust the bearing wall up, and that becomes my parapet. Kind of double checking, make sure I really got it. Looks like it was a little off. Adjust it a little bit. Okay. Do the same thing over here for the higher roof above the second story. Draw a sketch rectangle. Start it right at the top of deck. Make it 2 feet. I'm just going to extend it over. No sense having to draw it twice. And then I'll align my walls. And there we go. Got 2 feet parapets now for the whole drawing. It's really coming together. I'm going to verify my duct alignment here. As I said before, we pretty much got it in the right place, but we'll just go back and double check. So it's aligned with the plan, and it's not infringing in the joist space or the light space. I'm having a little trouble here because when I'm trying to select that duct, it's actually selecting the sketch rectangle. Not a problem, you just have to keep clicking on the object you want until this program recognizes that the object you want is there. So eventually I'll get it. Okay, now I've got it pretty well aligned with themselves and the plan. Zoom out. And we're really pretty close to done. The last thing, and pretty important, is to check your work. So I'll check architectural first. Looking at the second floor here, just want to make sure that our firewalls are, partition walls and bearing walls are all in the right place. It all aligns with the plan. Bearing wall looks pretty good. No partition walls, but we do have that firewall, and that's in the right spot at the corridor. Now we'll check our structural. We've got the joist orientations correct, and it looks like our section profile joists are in alignment with the plan. Now we'll check mechanical. We've got pretty good alignment now. Now we'll go down to the first floor and check the architectural. Got bearing walls and bearing footings and interior footings and firewalls and partition walls as they should be. We don't not really cutting through any first floor joists and laboratory, but it looks like the profile is correct in the first floor space. And now we look at mechanical, cutting through those two ducts there. And we can use the ID tool to check and make sure that we got the correct objects. So I'm just kind of clicking around to see, and you can look down in the bottom left corner that it tells me what the object is and its size. So it's looking pretty good. So it turned off everything, and there you have it, completed section. Looks really nice. That wasn't so bad, was it? By following these simple steps and procedures on the test day, this vignette shouldn't give you any trouble. Good luck, and remember that once you pass, you can move on with your life, and this will be nothing but a bad dream.